So welcome to Sakala Vidya educational channel. Today we are going to discuss uh, eigenvalues and eigenvectors regarding to the engineering mathematics, and it will be useful for B.SC as well as competitive entrance examination also, such as GATE examination and PGT and TGT examination. Okay, so we discuss some shortcut methods also regarding to the GATE examination and competitive entrance examinations. So eigenvalues and eigenvectors. So directly let us discuss the examples with the help of the examples. So after that we discuss different methods how to find out eigenvalues of a given square matrix and also how to find out eigenvectors corresponding to the required eigenvalues. So let's have a discussion on that one. So directly we shall proceed for the example now. Right, example. So first example, let's discuss. Find the So all of you look at the screen and note down the question and try to solve yourself. Then you check your answer after me. Find the characteristic equation of the matrix A equals to 2 2 1 1 3 1 1 2 2. So this is the question. So first let me read the question. Find the characteristic equation. Find the characteristic equation of the matrix A equals to 2 2 1 1 3 1 1 2 2. So that means here you are asked to find out the characteristic equation of the given here matrix A that we need to find out. So characteristic equation as well as the characteristic roots also we can find out. Sometimes it may be given as characteristic roots also. First let us find out characteristic equation. So next, how to proceed? So first write down solution. First given write down, that is given matrix, given A equals to 2 2 1 1 3 1 1 2 2. So these are the elements of the square matrix, that is 3 by 3 square matrix. Okay, first how to find out the first characteristic equation. So that means the characteristic equation, the characteristic equation of A, the matrix is modulus of A minus lambda I equals to 0, where I stands for the unit matrix, that is also 3 by 3 unit matrix. So let us find out this value A minus lambda I. How to find out A minus lambda I means very simple. I will write in rough part. A minus lambda I is known as characteristic matrix also. How can you get it? Just concentrate on the principal diagonal elements, that is 2 3 2. From 2 subtract lambda, from 3 subtract lambda, from 2 subtract lambda, and remaining elements will be same, 2 1 1 and 1 1, so that we shall get the characteristic matrix. So that means you get like this: 2 minus lambda, 2 1 and 1, 3 minus lambda, 1 1 2 and 2 minus lambda. So this matrix is called characteristic matrix. So we need to find out the determinant of this characteristic matrix, and it is being equated to 0 and expansion, so that we shall get the characteristic equation. So welcome Kumar and welcome Varun. Right. So let us move to next one now. So let us proceed for to find out further step. Right. First let us write here determinant of that implies actually here. So that implies we get like this, the determinant of 2 minus lambda and 2 1 symbols row 1. So now you get like this, see, next you are going to get like this. So my dear students, 2 minus lambda multiplied with the determinant of this matrix, so that we get 3 minus lambda multiply with 2 minus lambda and minus 2, and this will be minus 2 and multiplied with deleting this row, this column, determinant of 1 1 1 2 minus lambda, 2 minus lambda into 1 2 minus lambda, clear, and 1 into 1 1, that is negative 1, and plus 1 multiplied with, my dear students, deleting this row, this column, determinant of this matrix, that will be 2 and minus 3 plus lambda is equated to 0. Am I correct? Now check. Okay, inverse of the matrix also I shall discuss, don't worry regarding this one. So this equals to what you get now here. Let us simplify this one. 2 minus lambda. So now let us multiply these two. 6 minus 3 lambda minus 2 lambda, that will be minus 5 lambda, minus lambda into minus lambda plus lambda square, and minus 2, and minus 2 times here 2 minus 1 is 1, this will be 1 minus lambda. Is it clear? Right. Okay, plus this will be lambda minus 1 equals to 0. So let us simplify. 2 minus lambda, here this will be lambda square minus 5 lambda, 6 minus 2 is 4, plus 4 minus 2, minus 2 into minus lambda plus 2 lambda plus lambda, and minus 1 equals to 0. Clear? So let us simplify now here. 2 lambda square minus 10 lambda plus 8 minus lambda into lambda square minus lambda cube minus lambda into minus 5 lambda minus 5 lambda square minus lambda into plus 4, that is minus 4 lambda. This will be minus 2, 2 lambda plus lambda, 3 lambda, and minus 1 is equal to 0. I hope it's very clear too. Don't worry, Chaitanya Kumar, I teach even inverse matrix also. So next let us move to the simplification now. Simplification part. Check. First let us write actually this value, minus lambda cube. See, 2 lambda square and minus 5 lambda square, that will be minus 3 lambda square. So minus 4 lambda plus 3 lambda, minus lambda and minus 11 lambda, 10 lambda, that becomes minus 11 lambda. So this is minus 2 minus 1 minus 3, 8 minus 3 is plus 5 is equal to 0. So multiply with the negative sign, negative 1. So that you will get lambda cube plus 3 lambda square plus 11 lambda and negative 5 equals to 0. We get a cubic equation in terms of lambda. So you can check it now. This will be lambda cube. So 11 lambda. So you check it now. You check it here. So wait for a while. I did mistake here, I think so. Right, plus lambda square plus 11 lambda, right, 2 lambda square, right. What do we have? Right, let us check the steps now. 1 minute. I'll come back. Wait for a while. Right. Am I audible to you? Yes or no? You check the simplification once again. This is very, very important. Right. Let us simplify. So 2 minus lambda into 6, this will be minus 3 lambda minus 2 lambda minus 5 lambda. This is plus lambda square and minus 2. Okay, this step is clear? Yes or no? You need to chart. Right. Next we have, this is minus 2 times 2 minus 1, 1 minus lambda plus, so 1 multiplied with this will be lambda minus 1 equals to 0. This is 2 minus lambda multiplied with lambda square minus 5 lambda. So 6 minus 2 is 4 and minus 2 plus 2 lambda plus lambda and minus 1 equals to 0. Right. So now 2 lambda square minus 10 lambda, 2 into 4, 8, that is plus 8, minus lambda into lambda square minus lambda cube minus lambda into minus lambda plus 5 lambda square, right, minus lambda into plus 4, that will be minus 4 lambda. This will be minus 2 minus 1 minus 3 plus 3 lambda equals to 0. So let us simplify. How to simplify? First minus lambda cube write down, next 2 lambda square and 5 lambda square minus 10 lambda and 3 lambda. Next these two we need to simplify. Right. So first minus lambda cube write down, 5 lambda square plus 2 lambda square is plus 7 lambda square. So minus 10 lambda, 3 lambda, that is minus 7 lambda. So plus 3, this will be plus 3 and minus 3. Sorry, plus 8 and minus 3, that is plus 5 is equal to 0. So, right, multiply with the negative sign. Lambda cube minus 7 lambda square plus 7 lambda and negative 5 is equal to 0. So how to find out characteristic equation? It's very simple. To find characteristic equation, put lambda for A. So then here phi can be written as phi I. Because this is an equation, algebraic equation, we need to write matrix equation. So therefore characteristic equation is, instead of lambda A, so you will be getting A cube minus 7A square plus 7 times A. Instead of phi, you need to write phi I. So minus phi I equals to 0. So this is the characteristic equation. And also this is also called Cayley-Hamilton theorem also. So this will be useful for Cayley-Hamilton equation. So now using this characteristic equation we can find out the eigenvalues and eigenvectors also. So let us proceed further. For this problem only, let us find out eigenvalues. So or characteristic roots also they are called. So now write down, to find eigenvalues. Right. So consider this equation: lambda cube minus 7 lambda square plus 7 lambda minus 5 is equal to 0. So how to solve this cubic equation? That is very important now. So for that, actually here, let us follow this method. So first, Horner's division method, synthetic division method, you need to alpha cube coefficient is 1, alpha square is minus 7, alpha coefficient is plus 7, and this is negative 5. So first substitute lambda is equal to 1, starting 0 right up. So 1 into 1, 1 plus 1 right up. This is minus 6, negative 6. Negative 6 into 1, here negative 6. So you will be getting actually 1. So lambda is equal to 1. So that is 11. Sorry. 1 minute. Let us see. Okay, sorry. Here this must be 11. So this must be 11. 11. So you will be getting 11 here. Right. Right. Here write down 11. So 11 minus 6 is plus 5. So plus 5. Minus 5 plus 5, 0. Stop. So this gives us a depressed equation that is called actually here lambda square minus 6 lambda plus 5. So that means this part can be written as like this: lambda minus 1 times lambda square minus 6 lambda plus 5 equals to 0. So this we need to solve it. How to solve actually here? Lambda minus 1 is equal to 0. And then we get lambda square minus 6 lambda plus 5 is equal to 0. So we get one of the values of lambda, that is equal to lambda is equal to 1. Is it clear? So now we need to solve this one now. This is a quadratic equation. How to solve this one? 5. The factors of 5 are 5 1 ja 5. And also this we can write negative 5 into negative 1 also. By adding these two, negative 5 plus negative 1 equal to negative 6. That means we can split the middle term. So that can be written like this: lambda square minus 5 lambda minus lambda plus 5 is equal to 0. So lambda common, we have lambda minus 5. And negative 1 common, we have lambda minus 5 equals to 0. I hope it's clear. Next, lambda minus 5 common, we have lambda minus 5 into lambda minus 1 is equal to 0. So lambda minus 5 is equated to 0. We get lambda minus 1 is equal to 0. Am I correct now? So lambda is equal to 5 and lambda is equal to 1. So we get actually here 3 values of lambda. They are called eigenvalues or latent values or proper values of A. So therefore we can write like this, we can conclude like this: the eigenvalues of A are 1 comma 1 comma 5. So this is our answer. I hope it's very clear to you. So let us move to yet another problem. Okay, now let us move to second question. Find the eigenvalues. Tomorrow we shall have a discussion about eigenvectors. Okay, eigenvalues of 5 4 1 2. This is 2 by 2 matrix. So this was given JNTU examination. That is 2009, November 2009 question. This was previous question only, right? Let us proceed for the solution. So first step, what is the first step we need to do? Let us consider, so let A equals to 5, 4, 1, 2. First we need to find out the characteristic equation. The characteristic equation, the characteristic equation, the characteristic equation of A is modulus of, det of A minus lambda I equals to 0. So that means very simple. Just consider the principal diagonal elements. From the principal diagonal elements, just subtract lambda. So that means you are going to get 5 minus lambda, 4, 1, 2 minus lambda, and determinant, that of this one is equated to 0. So how to find out determinant of 2 by 2 matrix? Very simple. That is AD minus BC you need to follow. So that means you need to follow this step. How to find out? Here 5 minus lambda multiplied with 2 minus lambda minus of 1 into 4 minus 4 is equated to 0. So now 5 to the 10, you will be getting minus 5 lambda minus 2 lambda minus 7 lambda minus lambda into minus lambda plus lambda square minus 4 equals to 0. So now the terms can be rearranged. So this can be rearranged, lambda square minus 7 lambda. So 10 minus 4 is plus 6 equals to 0. It is a quadratic equation in lambda. So we need to solve it. How to solve? The 6 can be expressed as minus 6 into minus 1. So that the middle term can be split as minus 6 lambda, so that we can find out the values of lambda. They are nothing but eigenvalues of the given vector A. So that means let us proceed for the solution of this quadratic equation. Lambda square minus 6 lambda minus lambda plus 6 equals to 0. So now take lambda common, we have lambda minus 6. Negative 1 common, we have lambda minus 6 equals to 0. So that lambda minus 6 is being taken common out. We have lambda minus 1 is equal to 0. So that means left hand side has been factorized, that lambda minus 6 times lambda minus 1 is equal to 0. So now we get like this. Okay. So now the lambda minus 6 equals to 0. Clear? And lambda minus 1 is equal to 0. So my dear students, we get lambda is equal to 6 because it's a linear equation in lambda. So this is lambda is equal to 1. So therefore you need to write, so therefore the eigenvalues of A are 1, 6. So this is the answer. I hope it's very clear to you. Okay, let us proceed for yet another problem. So third problem. So let us proceed for the third problem. Find the eigenvalues of A equals to -2, 2, -3, 2, 1, -6, -1, -2, and 0. So this question was given JNTU examination, that is 2006 as well as 2008 also. 2 times it has appeared in JNTU examination, and it may be useful for different states also, it will be useful. Right, now we need to discuss. All of you just note down the question. First of all, you are asked to find out the eigenvalues of this A. Minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So, my dear students, all of you note down and just try to solve by your own. After that, check my method. Well, is it clear now? Okay, now how to proceed? First solution right now. Here given. So, what is the given matrix? That is A equals to negative 2, 2, negative 3, 2, 1, negative 6, negative 1, negative 2, 0. So now let us write the characteristic equation. The characteristic equation of A corresponding to the A matrix is determinant of A minus lambda I is equal to 0. Some textbooks instead of lambda S may be taken, no problem. But here we need to find out the values of lambda. So that means very simple. So 2 minus 3 and minus 6 minus 1, 2 minus 2 as it is we need to write just. So in the place of this diagonal we need to subtract each element of the diagonal with lambda now. So that we get determinant of minus 2 minus lambda, 2 negative 3, 2 1 minus lambda, negative 6. So negative 1, negative 2, 0 minus lambda is negative lambda. So determinant equals to 0. Clear? I hope it's very clear now. So now you are able to write this one now. Expand this one. Right, let us expand it. Let us expand it now. Right. Okay. Now we are going to find out the characteristic equation. So that means minus 2 minus lambda multiplied with, deleting this row, this column, you have 1 minus lambda multiplied with negative lambda. This is minus 12. I hope it's clear. You can check it now while simplifying. Next, negative 2 times, deleting this row, this column, minus 2 lambda. This is minus 6 and negative 3, right, minus 4. This is positive 1 into 1 minus lambda plus 1 minus lambda is equal to 0. So let us simplify. You should have very patient. So you must be very patient while calculating. So this is minus lambda into 1, something negative lambda into 1, negative lambda. Negative lambda into negative lambda, that is positive lambda square, and negative 12. And negative 2 times. So now wait for a while. Directly we can simplify. Right. So now this will be plus 4 lambda plus 12. This will be minus 3 into minus 3 plus 9. Negative 3 into negative lambda plus positive 3 lambda equals to 0. So now this can be rewritten. Negative lambda, negative 2 multiplied with lambda square minus lambda minus 2, minus 12, sorry. 4 lambda, 3 lambda, that will be 7 lambda. 12 plus 9, that is 21, equals to 0. Again, further we need to simplify it. Okay. So further we need to simplify this one now. Right. So now you can use the calculator also while finding the 1 minute. 1 minute. So now negative lambda into lambda square, that will be negative lambda square, negative lambda into negative lambda plus lambda square, negative lambda into negative 12, that is plus 12 lambda, negative 2 into lambda square, negative 2 lambda square or minus 2 lambda square, minus 2 into minus lambda plus 2 lambda, minus 2 into minus 12 plus 24, plus 7 lambda plus 21 equals to 0. So my dear students, in the examination you are allowed to, B.Tech students are allowed to use the calculator also. With the help of calculator you can solve the cubic equation also. So this will be lambda cube. This will be lambda cube, right? So now negative lambda cube minus 2 lambda square minus lambda square 12 lambda 2 lambda 12 lambda plus 2 lambda, that is 14 plus 21 lambda. This is 24 plus 21, that will be 45 equals to 0. Am I correct now? Right. Multiply with negative sign, you will be getting lambda cube plus lambda square minus 21 lambda minus 45 is equal to 0. Right. We need to solve it for the values of lambda. How to solve it? That means to find eigenvalues. To find eigenvalues of A. Right. This we need to find out. So first let us follow the synthetic division method. Write down here 1 plus 1, write down minus 21 and minus 45. So better you try, because 45 is not divisible by 2, but because 45 is an odd number, 45 is 4 plus 5, 9, it will be divisible by 3. So let us substitute negative 3 here first. Lambda is equal to negative 3. Start with 0. So 1, negative 3, this will be negative 2, plus 6, you will be getting negative 15, so plus 45. So you are getting 0. That means lambda plus 3 is one of the factors of this one. This is called depressed equation you will be getting. That will be lambda square minus 2 lambda minus 15. Clear? This is the depressed expression also you can write it. Now this can be rewritten as lambda cube plus lambda square minus 21 lambda minus 45 is equal to 0. Now the left hand side we can write as lambda is equal to minus 3, satisfy this equation. Lambda plus 3 is one of the factors. So this we can write lambda plus 3 times, and this expression write down. That is lambda square minus 2 lambda minus 15 equals to 0. Clear? So now we need to solve it now. So now how to solve this one? We get like this. Lambda plus 3 equals to 0. Here lambda square minus 2 lambda minus 15 equals to 0. So my dear students, minus 15 we can write minus 5 into 3. If you add these two, minus 5 plus 3, that is negative 2. So that means here middle term we can write as lambda square negative 5 lambda plus 3 lambda minus 15 is equal to 0. This is called, so factorization method we are applying. So lambda common, we have lambda minus 5, plus 3 common, we have lambda minus 5 equals to 0. Again, so we can take lambda minus 5 common out, and this will be lambda plus 3 equals to 0. Right. Lambda equal to minus 3, actually because 45 is there. 45 is not divisible by 2, because 2 does not divide 45, because 3 divides 45. I tried 3 because there are two negative numbers. I selected negative 3. So that is the reason. Okay. So now here we'll be getting two cases, lambda minus 5 is equal to 0 and lambda plus 3 is equal to 0. Good question you are asked, Mr. Marvel. Lambda is equal to 5 and lambda is equal to negative 3. Here also lambda is equal to negative 3. So therefore we can conclude the eigenvalues of A are negative 3 comma negative 3 comma 5. So this is the answer. Okay, we shall continue in the next session for the eigenvalues. Thank you, bye bye. I hope you understand. Once again watch this video. Thank you, bye bye.